A company is increasing the production of a product at the rate of 20 units per week. The demand and cost functions for the product are given by the two equations in the problem, where X is the number of units produced per week. Find the rate of change of the profit with respect to time in dollars per week when the weekly sales are 500 units. The demand function is the price per unit. In order to create revenue, because profit is revenue minus cost, we have to multiply P by X. In other words, if you're not given a revenue equation, you can create one by multiplying X times P. Think of it this way. It's the number of units sold times the price at which they are sold. For this particular problem, this is going to be equal to 50x minus 0.02x squared. Once you've created your revenue equation or function, then because cost function is given, we can now create a profit function. Profit is revenue minus cost. Revenue is the one we just created. We can steal the cost function from the original problem. Be sure to use parentheses so you don't mess any signs up along the way. Cost is 3,000 plus 20x minus 0.03x squared. If you distribute the negative sign to all three terms in the second set of parentheses and combine like terms from the front set of parentheses, starting with your x squareds, negative 0.02x squared minus a negative makes a total of positive 0.01x squared. $50x minus 20x, that's a positive 30x. And then the only constant is in the second set of parentheses. Distributing the negative gives you a negative 3,000. Taking the derivative of your profit function, and again, x changes with time as well, 0.1, whoops, just dawned on me I left that a 0 short. There we go. There's an easy fix. Okay, so multiplying, we get 0.02x for the derivative. Dx dt plus 30 dx dt. Remember, if the term has an x in it, even if the derivative takes that variable away, you still have dx dt. It still is a variable with a time component. In the original problem, we're given x equals 500. Dx dt is 20. That's in the first sentence. And then we'll do a 20 here as well. The first group of terms, 0.02 times 500 times 20, that's equal to 200. The back group, 30 times 20, how much is that? 600, for a combined total of $800 per week. And that's the rate of change of profit. In our second example, the profit for a product is increasing at a rate of $5,400 per week. The demand and cost functions for the product are given. X is the number of units produced per week. Find the rate of change of sales with respect to time when the weekly sales are 38 units. Rate of change of sales, that's dx dt. In the first sentence, we're given a rate of change for profit. So we've got to attack this one a little bit different towards the end compared to the first example. We still don't have a revenue function given, so that's the first thing we're going to find. R is equal to XP, X number of units times the price at which they're sold, which is equal to 7,000x minus 25x squared. Profit is revenue minus cost, and like the first example, we've got to build that. P equals R minus C. Revenue is the function we just built. Cost is given. Distributing the negative and combining like terms, we will get P equals, there's only one x squared term, and it's a negative 25x squared. 7,000x minus 2,400x, that's 4,600x. And then the only constant is 50. It's in the second set of parentheses, so minus 50. Very good. Be very careful. Taking the derivative, the change in profit over time, negative 50x dx dt plus 4,600. The x goes away, but because it was there, dx dt. The first sentence of our problem tells us that the change in profit per week is $5,400. X is 38. Dx dt is what we're after. 50 times 38. Be careful to also include the negative. That's negative 1900. Plus 4600. Now these are like terms because they're both dx dt terms. 4600 minus 1900 is 2700. And again, that's just simply combining like terms. Divide both sides by 2700. And you get dx dt equals to 2. And that was what we were after in the problem.